let's see, I was your age, 74. Yeah, 1974. And he did it while he was in Atlanta Brave. And then it was number 7, they went to 755 home runs. And then Barry Sanders broke his record, but that was it was contested. Barry Bonds broke his record, but Barry Bonds, the big thing was just how many of those were hit when he was doing steroids. And anyway, I got to see Hank Aaron once, face to face, like this close. He didn't sign autographs. And but they were dedicating some bronze statues in Milwaukee, and he was there for that. It was pretty cool to be able to just be next to the guy. He's only like this tall. He's smaller than me. He hit more home runs than anybody at the time. So, anyway. 17, did you say?
Just use all of 17.
All of 17. Can you tell me what all of 17 is asking? What's the question? Somebody read it to me.
Find the exact area of the circle. Find the exact circumference of the circle. If you double the radius of the circle, how many times as large is this area of the circle? If you double the radius of the circle, how many times as large is?
So do they give you numbers, or did they just give you?
No, they give
17 centimeters is the radius.
17 is the radius. So 34 is the diameter? Okay, so pi d for circumference. So then you have 34 pi centimeters for the exact circumference. So then what happens to the circumference when you double the diameter? Is that what they're asking?
Yes.
Okay, so if you double the diameter, what does it become? What's the new diameter? 64. So now you have this circle,
64.
right?
68.
Or 68. So then if we double that, then it's going to be 68 pi centimeters.
It said double the radius of it.
This is number 17.
Yeah.
And you're reading me the question.
But it said find the radius of the circle. It doesn't say anything about making it 68 pi.
Oh, somebody said something about finding the circumference. Should I read it to
Yeah,
it?
there's like 5 parts to the question.
5 parts?
There's A, B, C, D, and E.
Well, jeez, that's kind of...
So that shouldn't count.
Okay, so the exact area of, oh, geez, we gotta go all the way back to area. All right, we better do this one step at a time. So 17 is the radius. So 17 centimeters is equal to the radius. So the area of the circle is pi r squared. Okay, so the area then would be 17 centimeters squared. And that, what's 17 times 17?
289.
389?
289.
289. Times pi centimeters squared. So that's the area of the original smaller circle. Okay. Then what are we supposed to do? B, find the exact circumference. So that's pi times diameter, but we need to double the radius. So that's what I have here. So if we double the radius, we get 34 pi centimeters. Is that okay now?
Yes.
Okay, good. Then C. If you double the radius, how many times as large is the area of the circle? It's not twice as big, is it? I mean, look what I just drew. If this is 17, and then I double the radius, that circle's a lot bigger than this. Times 2, isn't it? So if we double the radius, now the radius becomes 34. So the area is equal to pi r squared. That area becomes pi times 34 centimeters squared. And 34 times 34 is a big number. It's like, how much? What's 34 times 34?
1,156.
Okay, 1,156. So here's what happens, we go from that to that when you double the radius. It goes from 289 pi, whoops, I'm missing pi in here, to 1,156 times pi. So how many times bigger is this than this? Is it 4 times?
That's what it said in the back of the book.
Well, I don't care what it says in the back of the book, I'm asking you.
Yes.
So, in other words, to go from 289 pi to get to 1,156 pi, you gotta multiply it by a number, some number. And is that 4?
Could you just divide it by?
Well, if you divide it by 289, yeah. Divide it by 289, cancel the pi's, what's 1156 divided by 289?
4.
That's 4. So it's 4 times the area. It's not twice as big. Yes.
You got like very different. I got different things, but I got the same answer. I did 34 times 2 times
Okay.
3.4
Time. It's not 34.
squared.
It's 34 squared, not times 2.
Yeah, 34 squared.
Okay?
So I got 34 squared times 3.14, and I got 213.52 divided by 106.76, and I got. Oh wait, sorry.
I'm not sure why you divided.
I was looking at the wrong one.
Yeah, I'd like to back up too. When they say exact, they want us just to leave pi in here. And the reason they wanted us to do exact and leave pi in there is then, like when we figure out how many times bigger it is, we have easier numbers to compare. That's the reason for that. So, are we okay then that it's 4 times? Would you like to know why?
Yes.
Yeah. Why is it 4 and not twice as big? If I write in red, can you guys see okay? Is everyone okay with red?
Yeah.
Okay. So what I'm gonna do is I'm gonna, here's the area, right? And then we doubled the radius to make it 34, yes? Okay, so watch something here. I'm gonna do the math, but I'm gonna do it a little differently. So I'm gonna do this math here. And that 34 comes from 17 multiplied by 2, right? When we doubled the radius, we took this times 2. Okay, so now the area is pi times 2 times 17 centimeters squared. This only works with multiplication. If this was addition, it doesn't work. But that squared can apply to the 17 separately and to the 2. So 2 squared times 17 squared. Because it's multiplication, you can break it up like this. What's 2 squared? 4. And the only thing that's different in this compared to this, in this case the 17 gets squared and then it's times pi. But here there's an additional 2 squared, which is 4. So if you made the circle 3 times the radius, it would be 3 times 3, or 9 times the area. So keep going. Do the answers to parts C and D depend on the size of the radius? So this is a tough question. Do you understand the question?
No.
Okay. So it's like, yeah, this is heavy
No,
stuff.
like it said, no.
See, for both, so for 17E, for both of the calculations that we did,
We didn't do D.
we didn't do D? If you double the radius of the circle, how many times as large is the circumference of the circle?
That's
It's 4 times.
Wait, isn't
And then
it
it's
just
E.
Oh, it's two.
Oh, circumference, oh, yeah. C says the area, excuse me, oh,
Yeah.
shoot. Okay, yeah, good, keep me straight. That's, okay, so, letter D, so C is area, D is circumference. Okay, so, that's the diameter when the radius is 17. So what's the diameter if you make the radius twice as big? So we had the original circle, which had a radius of 17, but now we're gonna, ooh, that's not quite twice as big, but we're gonna double it. Well, this is what I did. I did this before. So if you make it another 17 wider, now what is the radius? 34, so the diameter is 68. Okay, so the circumference is 68 pi centimeters. So we want to compare that to this. So we're comparing this circumference when the radius was 17 and the diameter was 34 to doubling the radius, making the diameter 64. What happens to the circumference? How many times as long is it? It's 2 times as long. Yeah, 68 pi versus 34 pi. 2 times 34 is 68. So it's not 4 times as long, is it? And here's why. You see, when we multiplied the radius by 2 in the area, that 2 would get squared because of the formula pi r squared. But in circumference, there's no squaring. It's just multiplying by the diameter. There's no second power. So then, this 68 is the same as just 2 times 34. So when you're dealing with one dimension, like length, that's the first power. There's no squaring or multiplying numbers by themselves. When you deal with area, then you have 1, 2 dimensions that get multiplied together. When you deal with volume, there's 3 dimensions. There's length, there's width, and then there's height. 3 directions. So that's the third power. We'll come back and do more with that later. Okay, then E. Do the answers in parts C and D depend upon the size of the radians? So that, what that's asking is, when you take circumference and you're calculating it from the diameter, does it matter what diameter you start with? If you double that diameter, will your circumference automatically just double? Or if you have different diameters, does it change how much longer the circumference gets? So here we used a diameter of 34. What if that diameter was 1,000,000? And you doubled it would the circumference still be 1,000,000 times longer? Or would it be,
Yeah,
oh, if you had a circle that's like this, with a diameter, and then you made it twice the diameter, or you started with a circle that was small like this, and you doubled the diameter, would both of those double the circumference?
Yeah.
Yeah, it doesn't matter how big the circle is. If you make the circumference, or if you make the diameter twice as long, the circumference is twice as long. If you started out with a little circle like this that had a small radius, and then you doubled the radius, it would be 4 times the area. And if you took a big circle like this and you doubled the radius, would you still get 4 times the area?
Yeah.
Yeah, it's because of that 2 that gets multiplied by the radius, and then it's squared. Or in this case, if you take just 2 and multiply it by the diameter, that doesn't get squared. So the relationship is the same regardless of how big the circle is. That was a long problem. What did you get for an answer for number 14?
2.07.
3.
I didn't get anything.
For number 14, that was the one where they shaded part of the circle.
I got it.
Then, so they had a 120-degree angle and they shaded the rest of it.
That's one third.
This is 1/3 that's unshaded.
Yeah, that's what
What fraction is shaded?
That's the one he told us.
that looks more like a quarter. Well, if you add 120 plus 120 plus 120, that's 360, that's a full circle.
Yeah,
That was 1/3.
You hear what TJ said? If you had 120, 120, and 120, that's 360, which is a whole circle. So the shaded area is 2/3. Of
360.
I don't know, what are they asking? They're asking for area, aren't they? Find the area of the shaded sector. So it's 2/3 of the whole circle. What's the whole circle's area?
I don't know. R times I squared.
Pi r squared. It's still pi r squared for the area. But we're just gonna take 2/3 of that circle. So we take 2/3 times pi r squared. So there's an exact answer. And then if you put pi in here and multiply it by 2, there would be 6.28 divided by 3. So this would become 6.28 divided by 3 times the radius squared, and that's a little bit bigger than 2. But all they told us with this circle was that the radius was r. They did not give us numbers. So they want you to work with the equation as it's given, or this formula for finding area. And one of the big points behind this lesson is that when we have formulas, they act the same on all sizes. And we're just doing it with circles now. Like if you had a rectangle, which had a length and a width, if you doubled the length and you doubled the width, you would make the area 4 times as big. If you tripled the length and you tripled the width, then it would be 9 times as big, 3 times 3. The circles, when we did this problem here, it's the same idea. because that radius gets multiplied by itself. Here, the width and the length get multiplied by each other, so there's two numbers again. Want to ask anything else? Do you guys have graph paper?
We have dot paper.
I'll give you graph paper now and then. Do you need some? Yep.
Doesn't matter how many pieces they need, or?
I didn't choose for sure. Unless they say no, I got like huge amounts.
Dose. You want to put an S or you start?
Here's one plate, maybe you can write it, or squeeze another out. Oh, you have a lot. Okay. You need some too?
Sure.
Yeah?
Miss Marsh.
What was I gonna do with these guys today? Size change model, but then, I don't know, my week is all messed up on my computer.
We only have like 5 minutes too.
Yeah. How many minutes do we have?
10.
10? Jeez. Yeah, sometimes things move slower than other times. That's just because I'm getting old. Priorities though, priorities. I usually get something on that is more like late Sunday afternoon.
Like Bill's gear?
Yeah, no gear, no
I
nothing.
saved my sweatshirts for the weekend.
Yeah,
She has her keychain.
I have my coffee cup and my keychain, and then my clothing is the weekend.
I haven't washed my shirt all year.
And my mask.
Weird.
Really?
You should
Okay.
wash it.
I have a quiz scheduled, but that's not gonna work. We're literally not gonna do it in 10 minutes. So we'll just do it later next week, but we will not do it on Monday. Okay? We will not do it on Monday. We'll do it later in the week.
What's it on?
Like Wednesday.
It's be on lessons 4, 5, and 6.
We should do it on Wednesday.
So it's not on circles. Is it? Yeah, it's on circles.
Wait, so this was 7-7.
No, this was 7-6.
Well, I thought the last assignment was 7-7.
it's on the area of
Well,
Oh,
so circles is 7-6, and then what we're gonna do is we're gonna go into 7-7. But we're gonna break up 7-7 into a couple of days. Can you do this first? Could you, put in, you probably don't need, I don't know, maybe you do, yeah, use the whole sheet, but do this. Set this up so that you have your X and your Y axes offset a little bit to the left. So instead of putting your Y-axis right down the middle, vertically, why don't you move over like 1, 2, 3 lines or so? Put a Y-axis, and it doesn't have to go all the way to the bottom of the paper.
How long do you want it? Like, how long is this end up gonna be?
2/3 of the paper from top to bottom. And then put a X-axis through the middle of that 2/3. Would you like me to draw a diagram on the board?
Maybe.
Maybe? So here's what I'm thinking. If this is a sheet of paper, you're over about this far with your Y-axis, and you come down maybe 2/3 of the way, and then you go across with your X-axis. Now I'll give you a little bit of writing room over on the side.
Mine is split. So, it's like,
You got two sides to it. And then I would like you to graph these points. Make sure you're working a pencil, please. Make sure you put your axes in with a straight edge. I'm gonna erase this now, Hayden. Is that gonna Wipe you out?
Just not, you just not do like A and B.
Well, why don't we just do this? Here, I'll shoot a picture of it,
Okay.
if I can get my phone to work. Yeah, I've got it on, as a picture, and I can give that to you however you want it.
And you have it on YouTube.
Yeah, that's right, it's on YouTube.
Is that good?
That's beautiful. Except that's a little too far over.
Aww.
So here are the,
I'm literally being forced.
these are the points I'd like you to graph, please. 0, 1. 1, 1. And when you label the points, label them only with the letter, not with the ordered pair. So for example, if I came over 1 and up 1 and I was gonna put point O there, I would put a little O next to it, not O, comma, or O, 1, comma, 1, just the O. And then here we're gonna get I, which is 1, 0.
Do you want us to put the, coordinates when we label it,
Nope,
or just,
just the letter, not the ordered pair. So you're gonna be packed in pretty close with all this, right? And then what I'd like you to do is off to the side, away from this, pretty far away from it, I'd like you to create a table. And the table headings would be like this. The first column is gonna be X comma Y. And that's where all of these are gonna get written. So it's gonna look like this. Yeah? So you're gonna have what? 0, 1, 1, 1, 1, 0, 3, 0, 3, 1. Mm-hmm. Yeah, those are correct. You're all good. C-I-N-G.
That's tiny.
What do you do? So now, off to the side, way over on the edge of your paper, set up a T-table like this. And then leave the right column blank for now. Are we out at 10 till? Is that right? Yeah, we are. 10 till. We got all day.
9:46.
Golly. You come grab a color that you can discern from another color and outline in order from P to O to I to N to T.
we got 2 colors then?
Um,
I'm so,
and this time,
Wait, you what?
just take one for now.
that was circle.
Just connect the dots?
Yep, you're gonna connect the dots in that color.
This is kind of what you want.
Hayden, do you have your phone in here?
Did you just not see it, Steph, Harlan?
I sent that picture to you, Hayden. So you're just gonna connect these points, so you're just gonna have the line going over, down, across the axis, and then back up, right? P to O to I to N to T.
Looks like a little.
Looks like a little measuring cup,
Like a spoon.
a little spoon with a pointer on it. It's like this.
A little dipper?
It's like a little dipper, there you go. Are we all there?
Yes.
Okay, then here's what I'd like you to do. I'd like you to change the size of your figure by a magnitude. Magnitude's a measure. By a magnitude of 3. So we're gonna do a size change to this. So what we're gonna do is we're gonna take each of the coordinates and multiply them by 3.
Wouldn't that be still 0?
Yeah, in this case here, 3 times 0 is gonna be,
0.
and 1 times 3 is 3. Yeah, so go through, multiply everything by 3. And then you're gonna have a new set of ordered pairs. And these are gonna be graphed and named a little differently. So when we name this new point, we call this P prime and O prime. Prime means that there's been some kind of a change done to it one time. So O is gonna change to O prime, which is gonna have the ordered pair 3, 3. And if you get your table filled in, plot those points, but do not connect them, then you'll be like ahead of the game for Monday. On the same axes, yes.
Fine.
So you've got your original, what we call a pre-image, that's the little one that you have in the color that you chose. And now we have an image of that,
Smaller.
and the image is made by multiplying all the coordinates by 3. It's called a size change, or an expansion. We made it bigger. Yes.
I got like 2 points in the same spot.
Yeah, me too.
Yeah.
Okay.
Oh, you have 2 points in the same spot?
I only have 1
And
point in the
I
same
prime.
spot.
So I got I prime, which is a 3, 0.
How do you finish?
N prime is 9, 0. And T prime is, whoops, 9, 3.
Yeah.
Yeah.
N and I.
So N and I prime, huh? Okay, so here's how you do it. If, let's say this is your first point right there, and that's point N. What you can do is you just draw a little circle around it, and then next to it, you'll put I prime. So whenever we have 2 points in the same location. So, hang on to your colored pencil. Hang on to everything else, and we'll just see you on Monday.
Snow quiz.
Hang on to this.
Yes.
Yeah, we got a good
You didn't
place.
hear instructions clear enough. Hold on to the stuff you
Yeah,
have.
thank you.